Okay. Topic 3, water. Okay, we're gonna fly through this, inshallah. Um, طيب, water is the most abundant substance on the surface. La, la, la. I'm gonna go to the important stuff. These lists are usually what's important. Okay, what happens if there's no fresh water? Obviously, you're gonna get waterborne diseases such as cholera and typhoid, diarrhea, ishal, famine, which is, yeah, you can't plant crops. Okay, natural water. Okay, you should know what is dissolved in water. Okay, water from natural substance contains many substances. Natural water contains many substances, some of which are dissolved oxygen. Some people they ask, how is oxygen dissolved in water? طيب انه يعني it's just dissolved, the air just goes, the oxygen dissolves in the water. How do you think the fish breathe in the water if there's no oxygen dissolved? Metal compounds, you're gonna say, oh, what, two metals? Man, no, stuff like Na plus, Cl minus, هيك, stuff like this. Okay, they're dissolved. Like مثلا salt water has sodium in it, right? Like the one in the beach. Plastics, obviously. Sewage, obviously, يعني في sewage. Harmful microbes, obviously. If you drink beach water, you may get sick because of the presence of harmful microbes and bacteria. Nitrates from fertilizers, you should know this, because fertilizers, when you fertilize, you throw fertilizers in the soil, right? And then هون عندك الwater, هيك, right? So when it comes and it rains, the fertilizers in the soil, they leak into the rivers and into the water, and these fertilizers contain nitrates. So that's how these nitrates are actually found in natural water. And the last one is phosphates from fertilizers. Same explanation. Some of these dissolved substances are beneficial, like the dissolved oxygen for aquatic life, and the metal compounds provide essential minerals for life. Like مثلا the Na plus, the fish need sodium ions. You may also find calcium ions in the water. These are beneficial, while others are harmful, such as some metal compounds are toxic. مثلا mercury is Hg, right? Hg, wait. Yeah. Mercury is found in actually most fish farms, and it's very toxic, especially sushi farms. When they harvest salmon and tuna and whatever, they start to find mercury. So these are the toxic metal compounds. Some plastics harm aquatic life. I'm sure everybody on Earth, especially if you're in this grade 11S or 11L, have heard about the plastics and whatever. Our generation went through it, the turtles and whatever. Sewage contains harmful microbes which cause disease. Obviously, the sewage, I'm sure you won't want sewage in your water. And the nitrates and phosphates leads to the deoxygenation of water, and they damage aquatic life. أكيد. Further sources of pollution may include acid rain, as we discussed in topic 2, the air. Power stations which generate electricity consume huge amounts of water for cooling purposes. When water is returned back to the rivers and lakes, it will be hotter, which decreases oxygen solubility, and therefore aquatic life will suffer. So, I don't know if you guys saw this, but this was trending the other day. ChatGPT, anytime you would ask it for to write you one paragraph or one essay, because it's run by a computer in a server back in the United States. So this server requires cooling, and they cool it through water. So whenever you ask it to write you one paragraph, it actually requires, I think, 1,000 liters of water to cool down the computer that runs ChatGPT in the United States to provide you with that one paragraph. So that's 1,000 liters of water per paragraph. So I just want to put it into perspective that you use these water to cool down computers and cool down power stations, and after it cools down the computer, the water itself is going to be hot, right? So when it gets released back into the ocean, this hot water, it doesn't allow oxygen to dissolve as easily, and therefore fish will suffer, okay, because they don't have much oxygen. Okay, name one natural phenomenon that can cause water pollution. Acid rain, right? Or volcanoes or lightning. Name the major, because they want natural, volcanoes or lightning. Name the other major water pollutants and classify them as organic and inorganic. So I'm pretty sure في table. So the organic water pollutants and the inorganic ones. Organic will be pesticides. Pesticides هني they're the دواء العقص. That's what we call it in Arabic. It's against pests. Pests is يعني هول الانسects. It's it's like medicine you spray in farms so that the insects don't come and eat your plants and crops. That's pesticides. It's organic. You have detergents. Detergents, I think laundry detergents, the soaps. I'm sure you're all familiar with it. Sewage is organic. Of course, sewage is organic. It's coming from us, from our body, so it's gonna be organic. Inorganic water pollutants, fertilizers, and heavy metal ions. How do you know if something is organic or inorganic? Organic is if it contains carbon. Inorganic is if it doesn't contain carbon. Okay, just think about it like this: they're all organic except the fertilizers and heavy metal ions, because fertilizers are made out of nitrogen, phosphorus, and potassium. Remember the NPK fertilizers? So there's no carbon. And heavy metal ions, طب خي, it's Na. Where's the carbon in Na? Calcium. Where's the carbon in calcium? You know what I mean? Okay. I explained how these are water pollutants because they leak into the water. When you spray it on the crops and the soil, it leaks into the water. Okay. Same thing with the detergents and sewage. Type. CQD8, water from natural resources may contain beneficial and harmful substances. Fill in the table to list the substance as beneficial and partially harmful. Okay. So dissolved oxygen, it's beneficial because it's for aquatic life. How can it be potentially harmful? Type, let's take a look at the answer because I honestly have no idea. Okay. What? Huh? Hold up. This is the table filled in. Okay, yeah, this is the table filled in. Okay, so you need to know this table. You need to know dissolved oxygen. Oxygen, there's no, and I was confused because what could you possibly put as harmful for oxygen? So oxygen isn't harmful, but it's beneficial. Why is oxygen beneficial? Because the aquatic life, they're gonna breathe it in. Metal compounds, how can be beneficial? How can be harmful? It can be beneficial because they're essential for life, for the aquatic life. And how can be harmful? Because some compounds are toxic, right? You should know this, that some metal compounds are toxic, like the mercury. I told you the mercury, it kills the fish. Sewage and harmful microbes, obviously there's no way it's beneficial. So these ones are only harmful. How are they harmful? Because they can cause a disease. Nitrates from fertilizers, phosphates from fertilizers and detergents, are they beneficial at all? No, they're gonna leak to the water and they will damage the aquatic life. Plastics, obviously they're not beneficial, they're gonna harm aquatic life. Okay, water treatment, there are steps involved in water treatment. Okay, you need to know these. Okay, sedimentation, filtration and screening to remove solids, then they sterilize it, and then removal of taste and odors by using carbon. So يعني خلاص, I'm gonna read it. Okay, water filtration, how does it go? I'm gonna see if I can get a picture for you. Okay, so this is the process. Okay, 1 second. Yeah, okay. I found a nice picture. Let me see. Can I copy this image and then paste it here? Can I? It's not pasting. Okay. خلاص عادي عادي. ماشي. Let me go to the notes. So how does it work? So you have water. You need to filter it out to remove the solids from the sewage, right? So the solid impurities are first removed, like the soil, plant parts, and organic waste and whatever. How do you remove it? By filtration, otherwise known as sedimentation. How does that happen? And they pass it through a screen. The solids stay behind, or the water continues going. So over here, the sedimentation tank. Okay, so the water goes in. All these solid stuff go to the bottom, or the water continues flowing. Okay. Then water is stored undisturbed, so the solids settle at the bottom in the sedimentation, like we did here. Okay, so this is how it's removed. The water is then passed through stone and sand filter beds to remove any solid impurities that escape sedimentation. So this is the stone and sand filter bed. It's a bed. The water has to pass through it. Okay, they do this as an extra precautionary method in case any sediment didn't leak here and sink to the bottom. So they do this so that any sediment that may be left over here will get stuck in this bed and then water will continue moving through. Okay. طيب. So it passes through the stone beds as to remove any solid impurities that may have escaped sedimentation. Then chlorine is bubbled through the water to kill bacteria. طب نحن what do we know about chlorine being bubbled? Where did this take me? Yeah, what do we know about chlorine being bubbled? There's only one use that يعني, I can think of, but chlorine being bubbled, why do we bubble chlorine? To kill bacteria, right? To sanitize it. Okay, so over here, after passing through the bed, we pump some chlorine into the water. What happens after that? To sterilize it and kill all the bacteria. Okay, then what happens? The safe clear water is pumped through underground pipes to houses. So هلا you have the storage tank, خلاص, to homes and factories. Very simple. Okay, in addition to chlorine, other methods can be used to sterilize water. These include UV light, right? You guys know UV light. مثلا, for example, families, I don't know about you, but I know in Arabs, usually, when we have, how can I explain this? Yeah, مثلا, like any clothing or bag or something that's like that needs cleaning, you would clean it and then we put it in the sunlight for 1, 2, 3 days, not to dry up but to kill any bacteria, because the UV light kills bacteria. So other than drying up the water from cleaning, it also kills the bacteria. And also to sterilize, you can add ozone. The addition of ozone kills the bacteria easily and can also attack some of the organic matter responsible for the bad smell. Ozone is a highly poisonous gas, so care has to be taken when you add ozone. Ozone, like I told you, is O3. I think I mentioned this in the other recording. Okay, briefly state how water is treated. So briefly, how do you treat it? أول شيء oh, this ain't brief, bro. Okay, so steps involved in water treatment are storage. أول شيء they filter it, then they aerate it, and then they sterilize it. Okay, storage. أول شيء you get the sewage water, you store it, then you filter and screen it, like we did. We filtered, and then we screened. Okay, and then what happens? We aerate it. Aerating is whenever you pass any bubbles, anything, but in this case, they're chlorine bubbles. Okay. Okay, and then sterilization is basically this. They're the same thing. Okay, so how does it work? You should know. Before treatment, water has soluble and insoluble impurities. Okay, what happens? Solid impurities are moved by filtration and sedimentation. That's the first step. So first step, sedimentation. The sediments sink. Okay. Okay, the second step is screening. Okay, the stone bed. Remember the stone bed. Okay, to remove further impurities. Okay, then the third step is what? Bubbling chlorine. Right? So, solid impurities are moved by filtration sedimentation. They sink to the bottom. Okay, and then water is passed through stone and sand filter beds to remove the solid impurities, any further impurities. Then chlorine is bubbled through the water to kill bacteria. Then the safe clear water is pumped through underground pipes to houses. That's it. In addition to chlorine, other methods can be used to sterilize water. What are they? UV light and adding ozone. Type. CQD4, polluted water is treated through a process of several purification steps in order to be used for domestic purposes. The following schematic diagram represents the water treatment process. At which stage is screening performed, and explain. At which stage is filtration performed, explain. Specify between which two steps sedimentation should be performed, and what do we call the last stage, and what is used to eliminate odor and taste of water at what stage. Okay, so over here we have water plus bacteria plus large solids plus fine solid, and then it undergoes process A to remove what looks like large solids, right? It removed large solids, so large solids. Okay, and then over here it removed fine solids by process B, so fine solids, the small solids. Okay, and then in process C it removes the bacteria. So at which stage is screening performed? Which one is filtration? I think screening is performed at B and filtration at A. I just need to make sure. Okay. For screening, this is the removal of large solids. See, this is the first time they use the word screening. It has a name, and I was saying there was a name, but for some reason, man, this is the problem. She writes notes, but she doesn't say the name of the processes. I don't know why. Okay, screening is the removal of large solids. Filtration is the smaller solids. Okay, so which one is screening? A. Explain what is there to explain. At this stage, large solids are eliminated. Okay, and then which one is filtration? B, because filtration is when small solids removed. Specify between which two steps sedimentation should be performed. It should be performed between A and B, right? Sedimentation, صح? Between screening and filtration. Yeah, between screening and filtration you have sedimentation. Why? To allow what is sedimentation? Sedimentation allows all the solids to sink to the bottom, right? What do we call the last stage? Explain. The last stage is called what they call aeration, right? Sterilization. Okay, sterilization. Why is it sterilization? Because you're killing the bacteria. So what's it called? Sterilization. Okay, what is used to eliminate odor and taste of water? اتفقنا انه it was to eliminate the odor and taste of water. We mentioned it up. It was ozone. Okay, at what stage is it added? It's added, when is it added? I don't know, Allah. At the end, right? Carbon. Yeah, for the bad smell. Ozone. Wait. Yeah, ozone should be correct as well. But here she put, yeah, in the course division it's carbon. I don't know, والله. خلاص, I guess both ozone and here, removal of tastes and odors by using carbon. Okay, so ozone should work, but whenever they say tastes and odors, tastes, you use carbon. So if they ask you tastes and odors, say carbon. Okay. At what stage is it added? It's added at the end, right? Before the sterilization step, so before stage C. Okay, this grid taught us four things. The first is that the removal of large solids is called screening, and it's the first step. The second is that the removal of small solids is called filtration. Okay. The third is that sedimentation occurs between screening and filtration. Okay. The fourth is that, well, sterilization we already knew it, but خلاص, we'll just say this is the fourth. The fourth is that the addition of chlorine is called chlorination or sterilization to kill microbes and bacteria. The fifth is that carbon is added before the sterilization step. And why is it added? To remove odors and taste. So, in my opinion, if you were to memorize something, it has to be this grid. Okay, you need to know this grid. You must. Okay, grids are what always come in the computer part. Okay, and I always see them come. Okay, so please make sure you know the grid. Okay, all grid questions are a must to know for all subjects because 80% of the grids must come. It's the rule in SABS. They must come in the final exam. Polluted water undergoes many steps in a water treatment before it becomes suitable for drinking. Which of the following steps is used to remove insoluble impurities from polluted water? Okay, so insoluble impurities. I don't know. Let me see. A. Filtration. Okay. Type. Filtration. نحن we said it's to remove the small solids. In other words, insoluble impurity. Yeah, okay, yeah. Insoluble impurities أكيد يعني they're talking about the solids. How do we remove the impurities from the water? From either filtration, إذا حطوا لك screening, this will be correct as well. Okay. What is coagulation? Addition of chlorine. No. What is coagulation? Okay, no, forget about coagulation. If we never took it, you don't need to know. Addition of chlorine, is this to remove insoluble? I think people will put addition of chlorine, but no, they're removing insoluble impurities, so stuff that it doesn't dissolve. How do you remove it? By filtration. Aeration, no, again, that's part of the sterilization process. E, none of the above, of course no. So it's gonna be filtration. If they put for you screening, that's also correct, okay? Removing taste and odors from water is an important step in water treatment. This is done by aeration. As water is mixed with air, any volatile impurities responsible for odors are released. And filtration through activated carbon. This removes taste and odors. Okay, so they filter it through carbon. Remember, filtration is the removal of small impurities, and screening is the removal of big impurities, in case they ask it, since it was in the grid. Okay, plastics and rocks are large solids. Okay, in case they ask it, huh? Okay. What substance can be used to remove taste and odors? اتفقنا, we use carbon to remove the taste and odors, right? CQD5, carbon. Some countries add sodium fluoride to the water to reduce tooth decay. This is not highly recommended because it leads to the appearance of permanent black lines in the teeth. Wow. Okay. She put it in the notes, but she can ask about it. Test for the presence of water. A hydrated substance is one that is chemically combined with water, while an anhydrous substance is one that doesn't have water. Pretty self-explanatory. The term water of crystallization refers to the water molecules present in hydrated crystals. Of the anhydrous salts, two are very useful to indicate the presence of water. What are they? Anhydrous copper sulfate and anhydrous cobalt chloride. These were in salt preparation, okay? So basically all this is yap. What you need to know is this, okay? These two salts are used to indicate the presence of what? Water. So copper sulfate, in the presence of water, it will turn from water, it will turn from white to blue. Think, copper is always blue, right? In the term, in the presence of water. Anhydrous cobalt chloride, it will turn from blue to pink, right? So remember, copper becomes blue. This white or colorless, huh? You can say white or colorless. Copper becomes blue, okay? And cobalt chloride, it turns pink, okay? From blue to pink. So fill in the blanks. So this is a grid, so you should know. When few drops are added of water to anhydrous copper sulfate, the observed color change is from what to what? Obviously from white to blue. And when they're added to cobalt chloride, it's going to be from blue to pink, right? So from white to blue and then blue to pink. How do you test water purity? By determining the boiling point and freezing point. So the closer it is to the boiling point 100 degrees Celsius and the closer it is to 0 degrees Celsius, obviously the closer it is to pure. So any pure material must have a sharp, fixed and definite freezing and boiling point. So if the liquid boils at 100 degrees Celsius and freezes at 0 degrees Celsius, then obviously it's going to be pure water. So pure water can only be produced by one process, and that is distillation. Okay, you can't get it by other than distillation. It's not good to drink distilled water. Okay, many people think, oh, it's pure water, it's good to drink. No. Okay, you drink water as a source of ions. Pure water doesn't have any ions, so there will be many health problems that will arise if you drink pure water. So we use water, the pure water, in practical chemistry because it contains fewer impurities. So in chemistry, they use pure water only in chemical reactions and stuff, just so they can experiment with it. How many types of water are there? Water from natural sources, distilled water, and domestic water. So natural sources, rain and whatever, beaches and oceans. Distilled water, which comes from the distillation of water, and domestic water that comes after filtration and treatment, right? How do you test the purity of water? You compare its melting point and boiling point. So it's tested for purity using its melting point and boiling point. If you have a sample of water that melts at 10 degrees Celsius, do you think that's close to being pure? No, that means it has a lot of impurities, right? Okay, why is distilled water used in laboratory experiments rather than tap water? We just said it, because distilled water has fewer impurities than tap water. هيك بنكون خلصنا الwater chapter. Very easy. Thank you so much for watching and good luck.